Today we're going to look at the use of the Pythagorean theorem. Now the Pythagorean theorem is used when you know the length of two sides of a right angled triangle and you're looking to find the length of the third side. So what is the Pythagorean theorem? Okay, Pythagoras determined that if he named the legs of a triangle A and B and the hypotenuse as C, and the hypotenuse is always opposite the right angle of the triangle, if he labelled those A, B and C, he determined that if you squared the side length of A and you squared the side length of B and added those two together, he found that they equaled the squared side length of C. So his theorem states that A squared plus B squared equals C squared, where A and B are your legs and C is your hypotenuse. Now, an easy way of writing these down for you to be able to remember when you're doing your assessments or even when you're just doing the exercises in your textbook is to simplify them down a little bit to C equals the square root of A squared plus B squared, if you're looking for the length of the hypotenuse. If you're looking for the length of the leg A, you can simplify that down to A equals the square root of C squared minus B squared. And if you're looking for the length of your leg B, you can simplify that theorem down to read B equals the square root of C squared minus A squared. Now all we've done here is we've rearranged that Pythagorean theorem, A squared plus B squared equals C squared. We've just used algebra to rearrange that formula so that it is easier to use. It's exactly the same and you can use it for all three of those functions. Now let's have a look at how we can use this. So we're going to use A squared plus B squared equals C squared to look for the length of the hypotenuse in this right angled triangle. So we've got leg A labelled 15, leg B labelled 20, and our hypotenuse is the one we're looking for, X. So we're going to label that C. So if we were using Pythagoras theorem and said, right, A squared plus B squared equals C squared, we substitute the values of A and B into the formula, square those numbers, which gives us 225 plus 400 equals C squared. Therefore, 625 is going to be equal to C squared. And then what we need to do is square root 625 to find the length of C, which in this case is 25. Now, the formulas I gave you on the slide before, these ones, they're going to make that a little bit easier for you so that when you write these formulas out, you can write them out like this and then substitute the values straight into these formulas, put them into your calculator and hit equals. You're going to save yourself a little bit of time and a few steps. Now, if we're looking for the length of a leg, in this case, the length of the leg is unknown. The length of the leg B, I beg your pardon, is unknown. A is 6 and the hypotenuse is 10. So again, all we're doing is substituting the values in. So we've got the leg A as 6, hypotenuse as 10, so we'd write it down as 6 squared plus B squared equals 10 squared. 6 squared obviously is 36, 10 squared is 100, so we need to determine what B squared is. So subtract 36 from both sides. That leaves us with B squared equaling 64, and then we need to square root both sides to end up with B, and then to end up with the square root of 64, which is 8. Now, applying it. This is where we start to get into a few difficulties if we're not careful. So the example here is a 15-foot ladder leans up against a building. The foot of the ladder is 5 feet from the base of the building. How high up the wall to the nearest foot does the ladder reach? Okay, the first thing we need to do is draw a picture. Very, very important whenever you're doing any of these to draw the picture so you've got a clear view of what you're looking at. So in this case, the 15-foot ladder is actually going to be our hypotenuse. So it's 15 feet, we label it 15. The foot of the ladder is 5 feet from the base of the building. So our X, our side A, is going to be the wall of the building. Side B is going to be the distance from the foot of the building to the foot of the ladder. So we label that 5. Therefore, we've got 15 as our hypotenuse, X as our A, and 5 as our B. Once we've done that, we just write the formula, substitute in the values, and solve for X. So in this case, we've substituted X in for A, 5 for B, 15 for C. So if we write it out as the original formula, X squared plus 5 squared equals 15 squared. Square those numbers. 15 squared is 225, 5 squared is 25. Then we're going to subtract 25 from both sides so that we're left with X squared equaling 200. Then to find the value of X, we need to square root both sides so that X will equal the square root of 200, which turns out to be 14.142135. Now, this is where you need to really check and see how you're going to leave your answer. If you have a look at the question, it asks to determine how high to the nearest foot does the ladder reach. So we've got to take a look at our answer and say we've got 14.14 feet. We need to round it to the nearest foot. Therefore, the ladder reaches 14 feet up the wall. Now, don't forget, when you are solving these problems, make sure that you round correctly, otherwise you will lose marks for incorrect rounding. Next example we've got. This is often a question that will just be a worded question. You won't have any pictures there, you won't have any diagrams there. You need to draw them in. So, we're told Tim rode 8 miles due north. So we've got to start at our origin. Pick a point. We're going 8 miles due north. Draw a line going up towards north. Then he rode 3 miles due east. So that creates our right angle. If we travel due north and then due east, we create a right angle. We've got our 2 legs. The first leg, being A, is 8. The second leg, B, which is due east, is 3. So they're in miles. How far to the nearest mile is Tim from where he started? So we've got to draw our diagram so that that line goes back to our origin. So it's really important that you draw the picture carefully and make sure it is accurate. So our hypotenuse is stated as X, and we've got our values for A and B. Next thing is to solve the problem. Okay, write your formula out. You can use A squared plus B squared equals C squared, if you wish. Or you can use C equals the square root of A squared plus B squared. It's up to you, whichever one's easier for you. So we're using the original Pythagorean formula here. So we're writing it as A squared plus B squared equals C squared, which is 8 squared plus 3 squared equals C squared. Square them out. 64 plus 9 equals 73. To find the value of C, we need to square root both sides. So C is going to equal the square root of 73, which equals 8.544037 miles. Now, once again, remember how you're supposed to leave your answer. And you were asked in the previous question, how far to the nearest mile is Tim from where he started? Please make sure you read your questions properly and answer them correctly. So Tim is 9 miles from where he started. Okay, to wrap it up, we use the Pythagorean theorem on right angled triangles. Okay, when should we use it? When we've got 2 side lengths and we have an unknown third side length. what we need to do when we're solving a word problem involving this is we need to draw our triangle and make sure we label it. It's very important to draw it correctly and label it correctly. And then when we're writing the answer, check to see whether your answer should be rounded down or up or not. Okay, that wraps it up pretty much for Pythagorean theorem. This should just be a bit of revision for you guys, and make sure you get your notes, draw your diagrams, label your triangles, and use either of those formulas that I mentioned before. Good luck.